Okay, transformations is, hopefully I can make this kind of make sense. It's something that there's a lot of notes on, but I don't know how, I don't know that we need to go over all this too much. So let's just go ahead. Okay, so the family of functions, the parent function of linear equations is always the same no matter what the line looks like, and we write it like this. The domain and range are both all real numbers, and you did this on your previous notes. The slope is 1, and the y-intercept is the origin, and it always is. Okay, so anytime you graph a line, we're only talking about lines here, no matter where it is on the graph, the parent function is f of x equals x. You can move it up, you can move it over, you can make the slope negative, it doesn't matter. If it's a line, the parent function is f of x equals x. Do not be tricked by f of x equals negative x, never a parent function. This is the only parent function for lines. We'll talk about parent functions for other functions later, but for lines, it's always this. Okay, so we're going to talk about transformations of lines. And you did this before in, I don't know, 7th grade, where you talked about reflecting and sliding and rotating. So we're going to kind of do those kind of transformations, but we're going to do them with lines. So look at this graph, and f of x is the shaded line. I mean the dotted line. G of x is the solid line. So when f of x is x minus 3, then every x value, we're going to subtract 3, and it's going to be that. If g of x is the same thing, but plus 5 more, then I'm going to take my negative 4, and I'm going to add 5 to it. So it's going to be 1, 2, 3, and 4. So you'll notice the line shifted up, and if you count 1, 2, 3, 4, 5, it shifted up 5. So the graph of G is shifted 5 units up from F. If a graph is shifted 5 units up from F, the resulting function is G of x equals f of x plus 5. So no matter what f of x is, we just added 5 to the value, and that's a vertical shift. Okay, so here's another one. F is this dotted line still. This time G is moved down. So let's count how far. 1, 2, 3, 4, 5, 6. So G is shifted 6 units down. If it's 6 units down, notice they still put a plus sign. It's going to be plus a negative 6. It's the same thing as subtracting. But when we want to do a general statement, we're always going to use the plus sign because then we can add a negative number and it doesn't change it. So let's look at number 3. If it shifted 3 up, g of x equals f of x plus 3. If it shifted down, then g of x equals f of x plus negative 2 or minus 2. But notice if we're shifting at d units, we don't know if d is positive or negative. So we're going to put g of x equals f of x plus d. And we know that if d were negative, it would be plus a negative or minus. Okay, if we want our lines to shift horizontal, it's a little bit different than the vertical shifts because notice what changed when we have this function right here. The change is happening to the x value. So we're changing the x value before we put it in the function. So if f of x was x minus 3 like it was above, then we would take our x value, subtract 5 from it, and then do the minus 3 that was in our function from before. So the changes to the x value, not the y value. So when it's the y value, it's a vertical shift. And if we're changing the x value, it's a horizontal shift. Okay, so if a function is shifted 5 units, and look which way the line went. The line went to the right. Then we end up with g of x equals f of x minus 5. And it's important to know that only for horizontal shifts, well, for horizontal shifts because of the changes happening inside. Inside the parentheses is always opposite. Okay, so horizontal shift happens inside the parentheses to the x value. It's always going to go the opposite direction of what the sign says. So if a function f is shifted 4 units to the left, I'm going to have to write it down here, g of x is going to be f of x plus 4. And if x is going c units to the right, g of x is going to be f of x minus c. Okay, so just remember it's always going to be the opposite direction of the sign inside the parentheses. You're not going to see a lot of horizontal shifting, but when it's inside the parentheses, the x value is changing, not the y value. Okay. Okay, let's talk about stretching, compressing, and reflecting. Okay, when we have, what's happening here is my x is changing, it's being multiplied by 3. So I'm going to have 0, 0, 1, 1, 2, 2, which you should realize is the parent function. And so my parent function looks something like that. If I multiply my x value times 3, then I have 3 so I have 1 and 3, 2 and 6, 3 and 9. So my line is going to be steeper. It's going to be 1 and 3. It's going to be 2 and 6. It's going to be 3 and 9. So my line's going to be more like that. Ooh, I missed it. Okay. So it's going to be steeper. 3 times steeper because everything gets multiplied by 3. Okay, so basically when you multiply x or y, this one happens to be multiplying x, the slope changes, not the y-intercept. When we shifted horizontal and vertical, our y-intercept changes. This one only changes the slope. So what do you think is going to happen on our next one when we have a smaller value? Here's our parent function again. Parent function. Okay, if we're doing, oh, and I was going to do different lines. If we're doing 1/4, let's just say that if we had 4, it's going to be 1 because we're dividing by 4. And if it's 8, it's going to be 2. So 1, 4, and 1, 8, and 2. So what happens to my line is it gets way flatter, less steep. 1/4 less steep. Or Yeah, 1/4 less steep. So the line is flatter. Again, the slope changed, not the intercepts. Okay, what do you think is going to happen if I have a negative x? Parent function. Okay, I'm going to change my x values. Instead of 1, I'm going to have -1, -2, -3. So my line's going to go 1, -1, 2, -2, 3, -3. So my line's basically going to have the same slope, same intercept, it's reflected across the y-axis. Okay. The last part, I'm going to do the descriptions and I'm going to let you draw the graphs. So let's think about what happens if we have multiple transformations happening at the same time. So for example, and this first one, remember this changes the, I hate writing in these boxes. This changes the slope and the second number changes the intercept. So from the parent function, remember we're starting with the parent function. This new line is twice as steep and shifted up 3. So it's going to be twice as steep and shifted up 3. So if that's our parent function, that's not going to let me do it, so I'm going to let you do it. Okay, so it's going to be twice as steep and it's going to be moved up 3. 3 is going to be the y-intercept. Okay. The next one from the parent function, remember we're always, for these, we're talking about the parent function being where we start. Okay, it's going to be half as steep. It's going to be flatter. And it's going to be shifted where? Shifted down because it's -5. Okay, and then the last one from the parent function. So draw your parent functions on these graphs first so that you can compare what happens to the new function. It's going to be reflected, which means it's going to have the negative slope, and shifted where? Down 4. Okay, so go ahead and draw the parent function and then the new function on all these graphs so that you can compare them and see what it looks like twice as steep and shifted up, what it looks like half as steep and shifted down, what it looks like when it's reflected and shifted, because a lot of times you're going to have two things happening at once, two transformations happening at once, and you're going to want to make sure that you are paying attention to which direction they go. See you tomorrow.